Actually, I should look up. There are a couple other nice. Oh.
So Mike said he only had work PCs back in, or as 3270 emulators to the mainframe. We, with the new Windows 10, we have to run a 3270 emulator to get back there because the old Windows 7 used to just have it. Like,
Yeah.
people are getting annoyed with having to run an emulator in the browser. It's not fun.
Well, at least you can run it in the browser. That's something.
Ish.
Yeah, so that might be a good one to try too. C12, GC 6946. I'll have to remember that. It might be a good one to go to over there. I got my start on a Trash 80, a TRS 80. That's where I started learning how to program. I'll tell you though, this box that we revived from the dead on Tuesday, it has a Dell service tag on it, but it's only five characters long, and Dell says, we don't know this service tag. An old XPS 166. Yeah. For a while, I had the TRS-80 voice synthesizer too. That was fun. Believe it or not, 1980s computers had speech synthesizers. Okay, about 3 minutes, we'll get started here, guys. I hope I have enough windows open here on all my desktops. That's why we also have Greg and Christine here to help. So if I do something weird, they can soft land it. If my computer decides to go to Mars for a second. But then the Apple IIe's that had the cassette tape drive. There's the good ones. Middle school had those. Let's see. Okay, guys, we'll get started in about 2 minutes here. We're getting a nice crowd. Actually, maybe I should get on Twitter and say, hey guys, we're starting. Got a sky and we're starting. People want to know that, right? Colon go. Good. Okay, there we go. Oh, Twitterverse. Okay. Start in about a minute. Yeah, and just like astronomy class, people are showing up in that last. People are showing up in that last minute. Okay, Greg and Christine, I'm going to rely on you guys. Once we get going, I'm going to rely on you guys to tell me if there's anything in the chat to react to, because I've got way too many windows open right now. So I'm going to rely on you guys to help with that. You did a good job last week, Christine. We'll just continue that. Okay, hey, it's 8 o'clock. I should get started. Hey, everybody, welcome to Star Party here on October 8th. My name's John Martin. I am the professor of astronomy and physics at the University of Illinois, Springfield, and you are here for a virtual UIS Star Party. So we've started. I'm going to remind you guys that actually, well, we're halfway through. We've got 3 more after this. Just reminding you guys, we do this every Friday night between 8 and 9 p.m. Central Daylight Time. And we've had a pretty good run here this fall, but we'll see what else we end up getting in here. I want to, as always, thank the people that have contributed and have donated to us. We are kind of a completely community-run thing here, and we try to, be really local oriented. And some of the toys we play with here, some of the stuff that makes Star Party enjoyable, was bought with money that was donated by people in the community. So I just want to thank people that do that. And also let you know that if you want to know more about becoming one of the people that helps us keep things going around here, that's our web link, go.uis.edu/ASP fundraising has more information. Okay, so I also like you guys to know about some of the tools we're using here tonight. The sky's so nice. I don't think I'm going to use the planetarium program, but I'll let you guys know I sometimes use that Go Skywatch planetarium program, which is free to show you guys things. I also, if you want to get started on the night sky yourself, a good place to get free sky maps is skymaps.com. They publish a free sky map every month, which is a good way to get started navigating around the backyard. I want to also, just for tonight, before I start, we'll thank him again at the end, but Christine Sonic and Greg Finn are both working tonight behind the scenes to make sure everything goes well and everything works here. They are our co-hosts tonight. I want to remind you guys also that Star Parties are usually pretty much about answering your questions also. So please ask questions. And here's how you can do that. You can either raise your hand, and you can raise your hand you can find it under reactions in your Zoom toolbar, or you can ask questions in the chat. You can find the chat on your Zoom toolbar, or sometimes actually on your toolbar, it ends up falling under the more right here. If it's not visible on the toolbar, click on the more. If you're on the mobile app, you're going to have to go to the participants menu to find your chat, but please, start loading up the chat with questions. Greg and Christine are going to be keeping an eye on it, and they're going to let me know as we have questions and I can answer them, because there are times here where I'm fiddling around with the equipment and I can just be answering a question or doing something like that. So please ask your questions as you have them. Okay, so I'm going to put that down. We're going to get to the fun stuff to start with. So I've got two cameras on the 20-inch telescope tonight. The first one, this one right here, is on, well, it's riding piggyback. This is actually our wide field camera that's riding piggyback on the telescope right now. We aren't actually looking through the telescope at this one, but this shows us a field of view about 2.5 degrees across and about 1.5 degrees from top to bottom. And this is live. This is coming off the telescope right now and taking an exposure every 10 seconds that we're seeing here. And if I come over here and I zoom in so we can see it more, what we're seeing here is we're seeing a star field that I'm pointed at. And you can see in this star field that there's something fuzzy at the center here that looks a little different. I'll say actually this star and this star, and the star down in the lower left-hand corner, you can see the two bright ones. Those are ones you can see with your naked eye. Those are two stars in the end of Lyra the Harp. And we see that sitting right between them here is this little fuzzy thing, and that is the Ring Nebula. The Ring Nebula has been one of our kind of go-to things for star parties, even in person for many years. It's pretty bright and easy to find with a small telescope because you just look between the two stars on the end of Lyra the Harp. Now, this is the wide field one, but if I come back over here, this is our narrow field. This image right here that we have, this, if I can zoom in, make it fill the screen, this is actually looking through the 20-inch telescope. This camera is on the back of the 20-inch telescope right above my head right here, right now, and it is looking through where we would put the eyepiece. Right now, these are 30-second exposures we're taking and stacking together to make this image. So you can see actually when we compare, it's gonna let me here, when we compare what we could see in the wide field image, that we're really zoomed in when we look through the big telescope here to see the zoomed in image. So what are we looking at here? This is a planetary nebula. So a planetary nebula is basically just a dead star. It has nothing to do with planets. We can talk about later why exactly it's called a planetary nebula. But it is basically after a star like our sun goes through its red giant phase, it throws off its outer layers kind of in a dynamic instability that we don't fully understand, but it does it, and it throws off the outer layers and they become an expanding cloud of gas around the white dwarf that's left at the center. That white dwarf at the center is basically the burnt out cinder of a sun-like star. It is the core where the nuclear reactions had been happening, and it's packed so tight that a teaspoon of it would weigh about a ton. That's how tight it's packed. And we can see our white dwarf right here in the middle of this planetary nebula here. That bluish star in there, blue means really hot, is that white dwarf. And the cloud of gas expanding off it are those outer layers of the red giant that were thrown off into space. The colors are due to different temperatures and different elements that are ionizing actually in that cloud of gas. So toward the center, most of the heat and light that is causing this cloud to glow is coming from the white dwarf. And the white dwarf produces a lot of ultraviolet radiation. And that ultraviolet radiation is ionizing some of the gas in the nebula. And it's hotter, higher ionizing radiation toward the center. And so toward the center, we see this greenish hue. And that greenish hue is due to oxygen being ionized oxygen. And there's a very bright ionized oxygen line at about 500 nanometers, right in the green part of the spectrum. So that's what makes this kind of greenish glow in the center. It's the hottest part, and it is glowing with the oxygen that has been excited by the ultraviolet light from the white dwarf. Then around the outside, you see on the outer edge though, you start to see red. The red is hydrogen emission. Hydrogen is ionized at a slightly lower temperature. And so further out in the cloud, further out on the edge is where we get the hydrogen emission that we end up seeing. And it's kind of a neat rainbow effect where the hydrogen emission that's red and the oxygen emission that's green all overlap, and you get kind of some yellows in there as well. So this cloud we think is roughly spherical, but because you're looking through it this way, you see kind of the edges more clearly than looking through the thin part in the center. It's like a thin shell going outward. And so in projection, it looks kind of like a donut. Or one of my favorite was I once asked a kid at Star Party, you know, well, we used to do this in person, looking through the eyepiece. I asked the kid to describe for everyone what they saw. Best description I ever got on this one, a ghostly Cheerio. Usually has something to do with food. So please feed your kids before you take them to Star Party. They're thinking about food. Okay. So actually at this point, let me see if there are any questions out there. Greg, Christine, do we have any questions in the chat or anybody raise their hand at this point at all?
Yes, we have one in the chat. Burker asks, how far is the nebula we are looking at, and how long ago are we looking at?
Good question. Without a very clear answer for this nebula. So I don't believe that we have been able to measure what we would call the geometric parallax to this nebula, because it's too far away to do that, even with some of the satellites we've used. And so we have to estimate it basically by looking at kind of the expansion velocity of the nebula and scaling that to its size, right? Because if we can use a spectrum to tell how fast the front side of the nebula is coming towards us and the back side is going away, we can kind of use that then to draw backward in time for how long it took to expand. And then if we measure the size of the nebula, we can guess at its distance. So this nebula is around 1,000 light years away from us, but we don't know that very accurately at all. So that means that the light from it is only 1,000 years old. Not bad, it's kind of in our neighborhood. I'll point out actually that since these nebula are expanding clouds of gas, that they do not last a very long time. In about 10,000 years, this cloud of gas will have kind of thinned out or expanded out enough that it get out thin enough that we won't be able to see it clearly anymore at all. But of course, at 1,000 light years away, that hasn't happened yet. So we're still able to enjoy it for now. Are there any other questions?
Yes, we have Hazel asks, can we see constellations? I assume that she was talking about the wide frame.
Yeah, so actually, well, actually, this might be a fun thing to do for people. I am going to show you on my planetarium program which part of the sky we are looking at. And we can match up what we're seeing in the wide field here with that. That might be really fun to do. So what I'm going to do is I am going to share, let's see if this will work. I need to share my iPad via AirPlay, and let's see if this works out. Okay, it's thinking for a second. Let's see if it'll do it. Okay, yes, awesome. So guys, just a quick tour here. So the sun has gone down in the west. This is basically the sky right now out at the observatory. We see that the sun has gone down in the west. The moon has just set over here. Venus is about to set. If you then look straight up in the sky, right over our head, now there are lots of stars here, but do you see this one, and this one that are bigger dots? If you look straight up in the sky right now, you see those 3 stars overhead, and that's the summer triangle. These are the stars Vega, Altair, and Deneb. And where we're looking is actually right here. So I'm going to move my cursor here and zoom in, okay? And if I zoom in here, and I'm going to move that little circle so we can see, we zoomed in on Vega, which is one of those stars in the summer triangle. And Vega is part of the constellation Lyra the Harp. And I'm kind of drawing Lyra the Harp in here right now. Okay, so you can see kind of it's vaguely a harp shape, okay? The strings. Now, we are looking basically just right here. That is what we're looking at. That purple thing marks what we are looking at in our other image. And the image is tilted so that this star is the one we see in the upper left corner of that image, and this star is the one we see in the upper right. So we can see basically a field of view that is something like this when we look at the wide field over here. So let me go back. I'm going to clear my drawings. I'm going to change my share back to my desktop. Oh, I got to turn off the notate to do that. And when I do that, oh, come on, new share, desktop, desktop 2, share. So you guys can see this star down here and this star down up there. Those were the two on the end of Lyra the Harp. And there is M51 right in the center. So that's kind of a good kind of guide for people that might go out and try to find it and see it also. Do we have any other questions? Any other questions right now? You know?
Yes.
Yes.
Jordan wants to ask a question. I'll let him unmute.
Okay, sure, go. Got to give him permission. You need some help with that, or you got it?
I think I got it. Jordan, are you there?
Go ahead, Jordan, with your question. Jordan, we think you're unmuted, but we aren't hearing you.
Hello?
Hello, yes, what's your question?
Okay, I have a question. So if a circle has a circumference of infinity, would that just be a line?
Hey guys, let's keep it on astronomy questions. Thank you for asking a math question, but why don't you ask your math teacher that one? Anybody else have a question? Okay. Actually, guys, think of those questions. We can do more of them. I want to focus on astronomy questions, not math questions. While we do that, I'm going to move us over to another object. The sky is good tonight, so we're going to just go ahead and move it on over to something else. Okay, let me see if I can get this done. Oh, I guess Jordan was just here to screw around. Well, that's fine. Okay. Let's go on and move over to, I am going to try next the Dumbell Nebula, which is another planetary nebula that we can see. The Dumbell Nebula is actually going to be M27 in the Messier catalog. So I'm going to my telescope control and I'm going to send it over. And oh, look, exciting things happen on the screen when I do that, right? You can see the telescope move. All right, I need to now turn the dome so that we can see through the dome slit. Okay, we need to wait for things to update a bit here. Oh boy, but can you see it? You guys see this? I'm going to turn down the red lights in here so that we can see it better. But do you guys see the Dumbell Nebula right there? Pretty exciting. One second, let me try to actually go ahead and I'm going to try to change this a little. Oh, it's doing the stacking. Awesome. Okay, guys. So you see the wide field of view here actually is showing us the Dumbell Nebula. I'm going to stop this and I'm going to sweep this out of the way. And we're going to, oh, I have a problem right now. I got to fix with the telescope. 1 second. Okay, something was dancing on the end of the telescope and moved it. Okay, you guys see the Dumbell Nebula there in the wide field? This is kind of neat. So you see that it has a similar color scheme to what the Ring Nebula had, right? This is another planetary nebula. This is another one that has basically another star that's taken and thrown off its outer layers into space and left behind this cloud of gas. And in this case, we see a slightly different shape with it. The reason for that is that we're kind of looking at this nebula from a different angle than we looked at the Ring Nebula. And we can see with this one, it has more of a bipolar design. In fact, you can start to understand why it's called the dumbbell, right? It looks kind of like a dumbbell design. Actually, kind of like an hourglass is another way to look at that. Let me see if I can get over here actually anything in this field of view. The problem might be with this one over here that I might not be centered on it. This is the problem. Oh yeah, I remember. I'm not going to do the main field of view actually here for the Dumbell Nebula because it actually is bigger than we see through the main field of view with the camera on the 20-inch telescope. This gives us actually a much better view. Well, let's let this one accumulate for a while actually here, because what the computer is doing right now is it's taking basically 10-second exposures. Every 10 seconds, it takes a new picture. Or it waits for 10 seconds and takes the delay to gather to makes a picture. It's stacking those together. So as we sit here and watch this, the picture's getting better because it's accumulating more images, more light, and you're going to be able to see more detail as we go here. You know, you can see when we started, you really couldn't see kind of some of the red tendrils in here, but now you can maybe see kind of a red X across there. I can't quite make out the white dwarf yet, but we'll see if we can get to that point. And actually though, while we're sitting here and watching that come in, which I really enjoy doing, does anybody have any questions actually, any other questions that have come up? And Christine or Greg, have we got anything in the chat or anything?
Yes, we do. Hazel just commented, I think it looks like an apple after you eat all of it.
And it could also be the Apple Core Nebula. That is true. It does look like that.
And then Bonnie asks, where in the sky is the Dumbell Nebula?
Oh, that's a great question, Bonnie. So I'm gonna have to remind myself right now, looking at it's right up there, Bonnie. So this actually, it's kind of in the Milky Way in the southern part of Cygnus the Swan. So if you're looking at the summer triangle up in the sky, right, those three bright stars that are over our head in the evening right now, and any of you guys that are outside right now can go and look at that up in the sky at the summer triangle. The Dumbell Nebula, is in the summer triangle kind of down nearer to Aquaia the Eagle, to the star Altair, which is the one in the south, the most southern star in the summer triangle. So that's where this one is in the sky right now. It's also pretty high over her head at the moment. Any other questions?
Yes, Deborah asks, can you tell us a little about the meteor shower tonight?
Oh, there's a meteor shower tonight? Actually, I don't know about the specific one. I'd have to go look it up. Greg, can you Google that for us quick? See if there's something that's supposed to be going on tonight?
I think it's the Draconids.
Oh, the Draconids. Okay. So not a very active or bright, one known for very bright meteors. So just in general, what a meteor shower is a meteor shower is a time when we pass through kind of a trail of debris left behind by a comet. And because as the comet flies through the solar system, it's melting and it's losing its outer layers. And if we pass, if that comet passes across the Earth's orbit, and a position the Earth moves through later and drops stuff, we can run into that stuff and get more stuff hitting our atmosphere, lighting up as it enters the atmosphere, and we call those meteors. So a meteor shower is when we pass through kind of a trail of debris left by a comet. So tonight, the Draconids, that would mean that the radiant, the place where all the meteors appear to come from in the sky, is in the constellation Draco. And Draco is up in the northern part of the sky. So if you can find north, which a good way to find that right now, well, you have two choices. Kind of low over in the northwest, we have the Big Dipper right now. You can use the Big Dipper to find that. Another way to find north would be if you know where the sun went down, stick your right hand out. Your right hand is now pointing at north. And if you look up in that direction, you might, in the northeastern part of the sky, see a little W shape of stars. It's on its side. That's Cassiopeia. You're looking kind of in the right direction there then. So because this is a stream of material left from a comet, it appears to kind of be coming from a certain point in the sky and streaming outward from that point. Now, the Draconids, and Greg might have the Wikipedia page and be able to say more here right now, but my memory is right. Those are not known to often produce very spectacular showers, but there's usually like at least 1 or 2 active meteor showers a month going on. There's a lot of stuff floating around out there. And so, they aren't all as great as, say, like the Perseids or the Geminids, which are ones that tend to have much more brighter meteors and more meteors that we see. But it's still an interesting one, I'm sure. So if you were to go someplace dark tonight, get out. The moon's not up, so it's a good time to do it. Basically, go out and watch the sky. I would try to get someplace pretty dark away from the city lights. You look up, you might see a few Draconids. You might see a few of these meteors streaming out of the constellation Draco. And that'll add to the like 5 or 6 you would normally just see a night anyway, or an hour anyway, sitting outside of it. Even on a night without a meteor shower, you will see somewhere between 5 and 6 an hour. I have to move the dome really quick, if you guys don't mind. But while I do that, is there another question?
Not right now.
Oh, I'm sorry, I didn't hear that. I was moving the dome.
Nope, there's no questions right
No
now.
questions. Okay. How are we doing? This actually looks like a pretty good picture of the, I'm going to say hit the save button of M27. This is one of the better that we've gotten, actually, I think. I don't know. What do you guys think? Should we move on or give this one a little more time to develop? What do you guys think? Any preferences? I think actually if I move that toward the center, let's see here, it's toward the center.
Ricker says a little more time.
A little more time. That's kind of the wide field. We'll share this on social media once we built it too. Yeah, that's really cool. I really like these. You guys might have seen some of the other pictures we do on social media from the wide field one. There was one we did of the Cocoon Nebula. I think we spent 90 minutes on that. We aren't going to do that during Star Party. But this wide field camera can actually produce some pretty cool views. And we're just starting to play with it. And this is the first one I've really done of the Dumbell Nebula. I almost called it the Apple Core Nebula. Even better. Well, what did we think? Has anything else shown up in the chat? Guys, that's the other way to get me to stay.
Yeah,
Record.
there's something.
Yeah, okay, let's take one more question here. I think about 15 minutes on each thing is good. I don't want people to get bored though.
Yes. Ricker asks, do you have a recommendation for an entry-level telescope?
No, but I can tell you where you should go to find more information. So there's a magazine called Sky and Telescope, and it used to every year publish a buying guide for binoculars and telescopes. Nowadays, in the days of kind of being able to find stuff on the web, they just have a page about buying telescopes. I recommend you check out the Sky and Telescope buying guide or buyer's guide. You might actually be interested in binoculars also to start with. Kind of what you want to do with the telescope will guide you a little. We'll step you through that, how serious you want to be. I'd say another great resource for finding out a type of telescope you want to get is your local astronomy club. Here in Springfield, we have the Sangamon Astronomical Society. I know up in Peoria, they have a very active astronomy club up in Peoria, also in Bloomington Normal and over in Urbana. Try to look up your local astronomy club and go hang out with them while they are doing observing. They're often happy to have people do that. And there you can ask people about their telescopes and maybe even, take a look and see what different things people have. And that's a good way to just kind of hear from the horse's mouth and hear from people that are using these telescopes, whether they work well or not, and whether they were satisfied in what they started with themselves when they were starting out. So that's my best advice for new telescopes. Yeah.
We have another question.
Ah,
Ancient
Ricker wants us to keep integrating, so I'll keep going.
Ancient Olmers Wizard of Time asks, what's the easiest nebula to find with a home telescope and how to find it?
The easiest nebula, I think, to find is the Great Nebula in Orion. Now, Orion is a constellation that is up in the evenings in the winter time. But right now, if you stay up really late at night, past midnight, and you're up well before dawn, you can see Orion hanging in the southeastern sky. And Orion has, 4 stars in its belt. It's one of the easier constellations to find, actually, when you're looking for it. And below the belt is a patch of sky that looks a little fuzzy to your naked eye. Even to your naked eye, it looks a little fuzzy. And if you aim a pair of binoculars or a small telescope at that, you will see that it's a nebula. It's this beautiful star-forming region that has a set of 4 bright blue stars in the center of it that are lighting it up. And it is something that is easy to pick out with your naked eye and then steer the telescope and the binoculars to. So that's really my piece of advice. And if you don't want to get up in the early morning right now, just wait a few months for the winter, and Orion will be up in the evening, in the late evening sky, and you'll be able to give it a try then. All right. How are we doing? Another one, or? Oh, I'm not looking at the stacked image. Let's try that, actually. But it didn't stack it. Oh, well, we'll try the next one. I saved a couple images, though, that looked really nice. So we'll just be happy with that for now. I think I had been looking at the single frame. Well, here, we'll give it a little time. Let's see. Let's see if it gets better. I was telling you guys we were stacking, and it was just getting better on its own. Our atmosphere must be, our telescope tracking must be good, and our atmosphere must just be settling down. Let's give this maybe 20 or 30 seconds. One of the things I said to you guys before also was that we call these planetary nebulae, even though they have nothing to do with planets. So when astronomers first were seeing these nebula, what they were thinking is that they might be clouds of gas around stars that were forming. And maybe those clouds of gas around the stars were forming planets. And that's where the name planetary nebula comes from. But today, we know they got the wrong end of the age spectrum, that this cloud of gas is actually expanding away from the star, and it's what's left over from a dead and dying star, not a new and forming star. Okay, we've stacked 7 images here. Okay, this is starting to look good. We should stack at least 10 or so. I think that'll look really nice. I think people are probably ready to move on here, though. I'll tell you that when you get to 9, you start your next point you need to get to for real good returns is 16. So here, we're at 9. And we'll save it, and we'll share that with people later. Okay, so why don't we move on to something else here? So what I'd like to move on to next, I think, is I would like to move on to, turn on my light, a nice globular cluster, actually, in Cygnus the Swan. Something else that is in the area of the summer triangle. And this one is called M56. So we're going to try this one out. Okay, and I'm sending the telescope, so wave bye-bye to the Dumbell Nebula. And it makes kind of interesting art. stars, right? Let me see, I'm gonna have to move the telescope a little, or actually the dome. Okay, I think I've got it. I've got it right there. You guys see it? That fuzzy in the middle of the field of view? I'm going to tell this, I am not going to make the same mistake. I'm going to tell it, start stacking these images, and we are going to do that there. Over here, what I'm going to do is I'm going to take this down to a 5-second integration so we can try to find what we're looking at here. I think that might be it off the bottom. Let me try and move things here so that I can try to figure this out. Okay. Here's the deal. Unfortunately, when I'm taking a 5-second exposure, oh, I'm in nowhere floating land. Sometimes the telescope does not want to behave. And we need to give it a little kick in the pants to get it to do what we want. This might be one of those circumstances. Okay, 1 second, people. We're doing pretty well over here, but I need to go ahead and try to move, or am I? Let me see the last image. The single frame is in about the right place. Okay. Deal is, I can't see it on the Finder telescope. If I could, that would make this so much easier. Maybe I can. Okay, I'm going to try to match up what I'm seeing on this field of view with what I'm seeing in the other field of view. I know I'm nearby. I'm going to send it. This is where if I had a nearby star, I could go a lot faster. But I didn't look that up ahead of time. So what I'm going to try to do is I'm going to try to use the wide field here to line up and it's going to let me do this. Okay, guys, 1 second here. I think that is that. So if I move to, and actually, if we have any questions come up while I am dithering around, please let me know. Because I can answer questions while I am trying to steer the telescope also. Here's the Ring Nebula. There we go. 56. So I can go to Okay, I'm going to go to a nearby bright star just to line things up, and then we are going to come back because that'll make it a lot easier. We're going to go to a no doubter. We're going to go to the star Vega, which I can actually line up with my eyes if we need to. Okay, so we're gonna get the star Vega in here. And the star Vega is, of course, the brightest star in the summer triangle. So this is one that is visible to your naked eye. Okay. And I am battling. There it is. I see Vega.
Hard to miss.
Hard to miss. Exactly. It is hard to miss. Okay, here's the good news. The center of my field that I have marked on the eye scope is still the center of my field. So we are going to actually go and say align from LASCO 2. And now, guys, we are going to try to send it back to M56. It turns out that M56 is not very far from the Ring Nebula either. Just looking that up. I wonder if that's it down there. Okay. I need to stop. I need to sweep. I need to restart. I am going to pull up another little tool I have. And actually, while I pull up the tool, oh, you know what that means? That means that the dome is in the way. Actually, things ended off just a little in declination there. So I'm going to try to do a faster. Uh-oh. Okay, guys. I wonder if I've got it here. Okay. Just need to be able to see one star to do this. All right, that's not it. Okay, so what I'm going to do is I'm going to check. We can obviously see it here. And so what I'm going to do here is I'm going to start our image stacking where we can see the image. Clear the stacked image. We are going to go to a 10-second exposure like we were before. And we are going to And I will let you guys watch this stack up. Well, I try to figure out where I have to move the telescope to get it in the main field of view, which shouldn't take that much work. But you guys got something to watch. And actually, are there any questions while I try to do this? Questions out there?
Nope, not right now.
Nope. People are just mesmerized with me flailing around with the telescope.
It's just getting an accurate, depiction.
Well,
of
yeah,
what's
this
actually happening.
is the way astronomy is done for real. Let's see. Okay, so if I zoom out, so what I'm doing right now, guys, is I am basically trying to figure out where the cluster is in my field of view, and it should be smack right there. Okay. I might send it to another nearby star just to get things lined up and then send it over. Six eight oh 40. Let's try that. Six eight oh. Yeah, this should take and center up. This will be good because now I can take and center up this star that I know is nearby. In my field of view. And then when I move to when I go ahead and I move to the globular cluster, oh, we're in a situation where it wants to go one direction declination, but not the other. We've seen this before, those of you guys that have done Star Party with the 20-inch telescope before. All right, it wants to move one way, but not move the other way. You guys just saw when I put my hand on the telescope that shot through the field of view. What this tells me is it's probably off in declination.
Mike was wanting to know if M56 was used in the Buck Rogers opening sequence.
I do not know. That's Greg. Could you look that up? I'd have to defer to Google on that one. Okay, this is at least close enough to where I have gotten that star in there. Oh man, I just need to move to another part of the sky where this is going to happen with the telescope. I'll check one more thing here. Oh boy. Okay, well, we'll try our best here with this. Everybody, cross your fingers. You know, a much brighter globular cluster that often gets a lot more of the love is a globular cluster called M13. M is in Messier 13. That one is a little further over for us to get to right now, though. See, it should just be like, I am right in the middle of that sucker. And so when I go to kind of the stacked image here, of course, it's dragging it all over the place. Yeah, I might have to try something else, guys, because I'm just, well, here, you can try this. It's going to help. Sometimes the telescope just doesn't want to point where you want it to point. But at least I can show you the view here. So what this star cluster is it is basically a cluster of about 10,000 or so stars. It's going to show me there. It's a cluster of about 10,000 or so stars. And they're all up double. Sweep the stacked image. Okay, there, this looks good. So it's a cluster of about 10,000 or so stars that is several tens of thousands of light years away. These are basically just giant balls of stars, star clusters, and the stars in them are really old. These clusters are some of the oldest clusters in the galaxy. Yeah, so I think the Sterna Buck Rogers has a globular cluster, and it might not be M56, but a more famous one that often is used is M13, or the globular star cluster Omega Centauri is quite a spectacular one to look at as well. So sorry we can't get this lined up right now in the main telescope, but we can get a pretty good look here, especially as we start to stack more and more images in here. Looking at the stacked image, we start to see more and more stars. These can look like kind of like taking a salt shaker and spilling it out on the table and just start counting all the little stars. The longer you look at them, the more stars you see. They're really neat to look at with small telescopes or pair of binoculars that way. Okay, this did not live up to what I wanted to, but I have 10 minutes left in Star Party, and so I want to try one that I'm pretty sure is going to live up what I want to, okay? And that one is going to be M33, one of the spiral galaxies, and Pegasus. And so to get there, I'm going to have to first get the telescope kind of in a better place where I'm lined up with things again. And I'm going to start that by sending it over to Deneb. But do we have any questions here before we do that? I want to do definitely a very nice ending one here for you guys, because you have been so patient here with everything we've been doing. Any questions right now? Everybody's like, go, 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 do it, do it. Okay, so so I'm going to start by sending this actually to one of the stars, the northernmost star in the summer triangle, which is Deneb, because M33 is actually over in the eastern part of the sky. Okay, hopefully we got Deneb in the field of view. And I do not have Deneb in the field of view, but I can do this by hand. Okay, and I will do this by hand. I think if I go and stop this and go to the single image, oh, well, there's Deneb, I've got it. Obviously, I have Deneb in the main field. I just need to make sure I move it more nicely into the field of the telescope. I can do that. I'm basically just sighting along the tube, and I can see Deneb. I've got a sight I can use to do this. Okay, and I've got it. All right, watch the main field of view there. We're going to pull this in. Yeah, there's Deneb. We've got Deneb. Okay. I'm going to tell that we are where we want to do. And then we're going to do this in stages. I have this one worked out already to send it to a star nearby that we can line up with, and then we know that we're going to the right place. So I'm going to send it to the star that's named SAO. 1 second here. Objects. I'm going to send it to a star that's named SAO 74872. 74872. Okay, that'll be our next way station on the way here. Got to turn the dome for this one. Got to go all the way around because we're over in the eastern part of the sky now. Okay, let's see if I got that star or if I have to line it. Here's the disconcerting thing. I do not see the star. Have to find something else nearby. I believe Alpharet, though, is nearby. Be a good one to use. Anybody remember how to spell Alpharets? Then I wouldn't have to look it up in the index.
With a PH?
Yeah, with a PH. I remember that much. Okay, here we go. Let's hope it's in here. Alpha, Alpheratz. This is one I'll be able to see with my eyes to line it up. Well, you guys might know before me if I was successful there. That looks like there is a star in my field of view, doesn't it? Try to get things lined up now. I think I got it. Yes, we kind of make kind of interesting art while we move things around on that wide field camera, don't we? You get different kinds of star trails as you see me moving the telescope one way or the other. I've got it. We just almost got it in the field of view here. There we go. Alpharets. Okay, centered up. Alpharets, we are where we expect to be. So now we are going to send it over to that other star. I need to move the dome again. Please be there. Oh, yes. And we are there. I'm at least close enough that I can move it in. Guys, we are going to get it. Give me 1 second. When I've got this star, once I've got this star in and locked in, we are going to have no problem finding M33. So hang with me here for a few more minutes. Okay, we are good there. Settings. Let's go to. And now we are going to send it to M33. M33 is a spiral galaxy that is in our local group. It is in the constellation Pegasus, and it is about 3 or 4 million light years away from us, million with an M. Okay. I'm going to need to set this up to about 0.5 seconds. It's there. I can tell it's there. You guys see that fuzzy spot in the middle of the field of view? Okay. I stepped on an electrical plug, so things might be coming back. I don't know if you guys can. Greg, how does it look? Can you guys see things?
Yeah, it looks good. I can see the fuzzy.
I got a little bit of a, oh, it's working itself out for me here. Okay, so you guys see that little bit of fuzzy right there? That is M33. And what we're going to do is we are going to take and tell it that we want to do 60-second exposures. And for that, I am going to have to take and change the dark frame on it so that I'm using the appropriate dark frame for a 60-second exposure. And we are going to say, run with that. Okay, now 60-second exposures means it's going to take some time, but watch this space right here. And my screen just went blank again. Greg, can you guys still see it?
Yeah, it's still stacking.
Okay. I did something weird with things here.
Oh, stop doing weird things.
I will stop. I will stop. Something got tangled and something's loose and pulling loose on the monitor. Can you guys see here with your eyes? You can actually see that fuzzy has some extent to it. I'm not imagining it there. You're going to see that sucker's real. I'm going to turn off this red light. That might help too. Actually, I wonder if the lights from my screens are also distracting it. Do we have any questions while we're waiting for this to stack here at all?
Nope, we don't have questions.
No.
Ancient Walrus Wizard of Time said that an asterism located in Corvus, very proximal to M104, resembles the jump gate or stargate in the Buck.
Well, we all love our sci-fi, right? Let this take a second. So, did I promise you or did I promise you? Let's give this a few, right? So this is actually the field of view. Then I can take and, you know, kind of do part of the field of view over here. This field of view is going to be very small compared to the galaxy itself. Remember, we draw like just a little triangle in the center for what we're seeing through the main telescope. But the wide field actually is going to pick up a lot more detail. You can start to see the nucleus of the galaxy right here. This is a galaxy that's shaped like ours, where it has a large, flat, kind of round disk shape to it with a bulge in the center. It has spiral arms. Can you start to see kind of those spiral arms in the first 2 images stacked? Actually, that's just 1 image stacked right now. As we start to stack more in, you're going to be able to see a little more detail here. All right, you see it starting to get in there. At 60 seconds a pop, it takes a little while. I'm very interested in this galaxy because you can actually, with the ground-based telescope here, this 20-inch telescope, we can take pictures that resolve individual luminous stars in this galaxy. And I am interested in studying the most luminous stars in this galaxy and watching them over time, because chances are that one of them will become the next supernova in this galaxy. We're observing it right now with our Luminous Stars project here. It takes us about 6 separate exposures through the 20-inch telescope to get the whole galaxy. We can't get the whole galaxy at once like we can in the wide field camera here. But when we're doing it with the larger telescope, we basically take an exposure and then move it and then take another exposure to cover the whole thing over time. It's 2. I know it's excruciating, right? Does anybody want to know anything about this galaxy? It's about 3 million light years away, as I said. You can start, it's fun. You can start to see its shape taking form here, right?
So if M33 is about 3 million or so light years away, how does that compare to Andromeda?
Andromeda is about 2 million light years away. So this galaxy is just a little bit farther away. And Andromeda is tilted in a way so that it isn't quite face on to us. We're looking at it kind of from an angle. This one is more to completely face on.
So I guess that kind of leads into another question of how are the galaxy angles, how are they distributed across the night sky? Do you have like a
Pretty much at random. Yeah, no, I mean, because there's no reason why they should be oriented any particular way with respect to us, right? We can see galaxies that are edge on, we can see galaxies that we call face on. We see Andromeda, that's something halfway in between. This one's more of a face on. And like the Sombrero galaxy, if you've ever seen that one, that's more closer to edge on, right? Where we see the bulge above and below the disk, and the disk is kind of just a line running through the bulge. Yeah, so, I don't know if we're running into clouds yet either, because that was supposed to happen maybe at 9 o'clock or so too, but we will let this run for a little while. We're starting to see some in there, and I hope that my light from my monitor sitting in the dome is not screwing with it also. That's always a possibility. But if you're starting to see kind of like almost a bar shape through here and like a kind of like arm there and kind of like an arm there, that's what's kind of coming out here. It's pretty much a grand design spiral. You can zoom in on the center here. Yeah, I can clearly see. You guys can maybe see more structure even when we're zoomed in here. You guys see kind of like the spiral shape that's taken form here. There's like an arm there. There's like an arm there. There's like an arm there. There's another kind of fainter arm that does that.
Jordan L wants to know, how wide is M33 from edge to edge in light years ballpark?
Oh, light years.
Or, normal people distances too.
Well, no, I mean, I couldn't tell you in miles either. I could tell you in angular size to start with. It's about a degree across on the sky. Maybe less, more like 40 arc minutes across on the sky. It's just slightly smaller than our own galaxy, and our own galaxy is about 100,000 light years across the disk, depending on if you want to measure the neutral hydrogen disk or the part with the stars. The part with the stars is about 100,000 light years across. So this one is probably somewhere in the neighborhood also of 50 to 100,000 light years across from one edge to the other. Oh, we've got 6 images in there now. I'll tell you, this bright star here is the bane of my existence sometimes, because when we take an image with the 20-inch telescope down here and that gets in there, it's what we say burns a hole in the CCD. It overexposes the pixels in a way where the CCD has to get warmed back up to remember itself again. And that's part of that part of the CCD. There's also, oh, here's another neat thing. You see this smudge right here? That smudge is a very large star-forming region. It's actually a very large nebula. It's about the size of, say, the Tarantula Nebula in the Large Magellanic Cloud. So several hundred light years across, and just hundreds and thousands of stars inside it forming. That's a real fun one to see. Some of these smudges actually you're seeing in those spiral arms are more, they aren't like individual stars, they're more star-forming regions. There are actually several kind of nebula like that in M33 that have their own deep sky numbers as a result. Yeah, now we're really starting to see this here, right? Now that we've got about 7 images. So I'll sit with this a little while longer for people that want to do this. But let me just say it's 10 minutes after 9 o'clock. I'm sorry for that little bit in the middle there where we kind of struggled with things. But thanks for hanging out. I want to again thank Greg, and I want to thank Christine. I want to remember to do that before most of you guys go. So let's round of applause for Greg and Christine helping things going. And I'll remind you guys also that we'll do this again next week. We're doing this every Friday through the end of October. And so we have 3 more that we're doing, or the 3 more Fridays in October. We'll be trying this out. So thanks for coming tonight. If you got to get going, I understand. We'll let this run just a little more here if you guys have questions or you want to see more of this. And of course, we'll post the picture when we're done on our social media as well, so you can see the one we made during Star Party. Thanks for coming tonight. Yeah, I mean, this is kind of neat. I mean, all the other things we show people, it's only a few thousand light years away, right? Did anybody have any questions? People are taking off, that's fine. They're like, we'll see the final image when you post it.
I always like this is how it's made kind of thing.
Well, it is fun. That's one of the fun things about this camera, that it gets to kind of just, it gets to accumulate. You know, I like what it does with the planets as far as like the very fast uptake on it. So you get the atmospheric motion and stuff looking at the planets. And I also like what it does as far as accumulating and being able to watch stuff come in that way too. Yes, so is M31 high enough up to view next week or wait until the end? Mike, so M31 and M33 are about in the same part of the sky, it turns out. And so I basically chose one or the other here. I could have just as easily gone for M31. The thing with M33 though is that M33 actually fits in the field of view, right? M31 is too big even for a wide field one. Believe it or not, you maybe saw that picture we took that we posted on Twitter of it, where we took lots of pictures and we pasted them together, and it took 2 pointings of the wide field camera here to be able to get all of M31. M31 is actually about 4. Let me get this straight. I think it's about 5 I think is the right number. 5 full moons from one end to the other. It takes up a lot of space. Yeah, it's a big one on the sky.
That's one thing that, you know, I've always wanted to. It's really hard to do it here, at least in central Illinois, is to go out and find a dark enough spot to see the full size of M31.
You need to go out west.
Yeah,
Go
and if
west, young man. Yeah.
yeah, that's one thing I want to do is head out to like Bufu nowhere, Oklahoma or Nebraska.
Well, the one place I've seen it that I can definitely recommend is here. I'm trying to find my stuff here. Is in West Texas at McDonald Observatory, where there you're about 200 miles from anything. You're in a county the size of Connecticut that has a population of maybe 1,000 people.
Nice.
And there, I was there once on a run where we did, where usually spectroscopists like me, people doing spectroscopy get bright time, but they had not used the dark time and the moon wasn't up. And so I got some of that. And I remember stepping out on the catwalk, the door shutting behind me, and all of a sudden I couldn't see anything. And I was kind of like, okay, I'm 2 stories off the ground on the catwalk outside the telescope dome. I'm going to back up to the wall and just let my eyes adjust. And as I did that, as my eyes adjusted, I was able to see with my eyes, this fuzzy thing up in the sky that was bigger than the full moon. I was like, what is that? What is that? What? It's the Andromeda Galaxy. So that's the one place I've seen it myself. And the other, so like out in the middle of nowhere, Western United States. Your other possibility, other good possibility actually is out in the middle of the ocean. If you can get them to turn off the lights on the boat long enough, out in the ocean is another neat place that you can go and see these.
Yeah, when I was in school in Arizona, we used to go out to one of the mountains out near Sedona, and I was out in the desert, and the nearest place is like 7,500 miles out, and it's a town of like 200 people, so their street lights are like 3 of them, and it's super super nice, and like that was probably the darkest sky I've ever seen. You could see
here. I found it. I'm going to show this. This is the one that we did, Mike. You can see kind of from the boundaries of these regions how we had to do it to stitch it together. And keep in mind that the moon is about this size, the size of the circle I'm making with the cursor on. So this was really wow. Yeah. All right. I was just looking, I couldn't find the images that I had saved, which is a little bit, well here, I'm gonna stop the recording because we don't need to record all